Deep below the warm, tropical waters of the Pacific Ocean, there is a dark and almost frozen world, a place so dangerous to explore that we know precious little about it. Finding anything alive there was once believed to be impossible. Conditions are so extreme that even the cells that make up all living things would be destroyed. Bones and shells would simply dissolve. The processes essential to life would come to a standstill. That was until 1960, when a creature was witnessed at the very bottom. The first signs of life had been found. But things got even more strange, because not only was life found at these depths, that life had adapted to here and nowhere else on Earth. Much of what we know about this secretive place comes from rare specimens that have been brought up by remote probes or are occasionally caught by deep-sea fishing. Strange creatures that have adapted to living in conditions that we still don't fully understand are sometimes washed up on our shores. Removed from their natural environment, they are distorted out of shape, often destroyed altogether, so we can only guess what they should look like and how they might live. The vast expanse of our deep ocean floors is the last unexplored frontier on our planet, waiting to be discovered. I'm James Stewart, and you're watching Astrum Earth. Join me in this video as we take a journey into the deepest of them all, the Mariana Trench. Our journey begins 150 years ago, when the British ship HMS Challenger was nearing the end of a 4-year mission, the first ever mapping of the ocean floors. They had already taken hundreds of soundings, a back-breaking job in all weathers, from blistering tropical heat to frozen polar waters, lowering a lead weight until it touched the ocean floor, then pulling up meter after meter of cold and heavy wet rope. The picture that emerged was of a featureless surface of mud and silt, around 3 to 4 kilometers below the surface. Alone in the empty ocean, 2,000 kilometers east of the Philippines, they were taking another routine sounding. On this day, however, the lead weight did not touch the bottom at 3 kilometers down, nor at 4, or even 5. It kept lowering into the deep. More rope was added, and still it went down. We can only guess how they must have felt as they tied on yet more rope. And that lead weight kept sinking into the depths, right underneath the thin wooden hull of their ship. Sailing the high seas in those times was a treacherous ordeal. The crews trusted their faith in traditions and superstitions. Legends told of enormous creatures that rose from the depths, gripping entire ships in their writhing tentacles and pulling them under. This sounds far-fetched to us today, but in those days, such fears were very real. Eventually, the weight hit the bottom more than 8 kilometers down. What they had found is now known as the Mariana Trench, and if they had been just a little further to the west, they would have found the deepest hole in the surface of our planet, the Challenger Deep. 11 kilometers down, Mount Everest would disappear into this hole, and it would keep sinking down 2 kilometers below the surface. The Mariana Trench is vast, a 2,500 kilometer long curved valley on the ocean floor, almost 70 kilometers wide. It begins 2,000 kilometers south of Japan, first curving southeast, then turning westwards towards the Philippines. The valley sides to the west are steep cliffs of exposed igneous rock. To the east it rises more gently, opening onto an empty ocean floor for 12,000 almost featureless kilometers until reaching Mexico. The scale is hard for us to imagine. Just the Challenger Deep alone, which is only a tiny part of the whole trench, could swallow up 5 Grand Canyons. The Mariana Trench is part of an almost continuous series of unstable and constantly moving chasms in the Earth's crust that encircle the Pacific Ocean. They are matched by a ring of volcanoes known as the Ring of Fire. An astonishing 90% of all earthquakes are caused by movements of this 40,000 kilometer fracture, where rock faces, many kilometers deep into the Earth, grind together and destroy each other. We are only now beginning to learn how the surface of our planet has changed over time, why the continents are arranged the way they are, and how these deep rifts in the planet's surface play a vital role in that story. To understand what created this remarkable geological feature, it helps to look first at the Atlantic Ocean, on the other side of the Americas. The surface of our planet is made from continents and oceans. That is not as simple as which parts are above water and which are hidden below the waves. The continents and the oceans are completely different components of the Earth's crust, all floating on a ball of hot rock called magma. Think of the continents as icebergs floating on an ocean of magma.